Hi there! In this week of the course, you will learn to solve systems of linear equations. But before we go into solution methods, let's take one step back to answer the question, what is a linear equation? I assume that you know what an equation is. It is a mathematical way to state that two expressions are equal. It may involve all kinds of mathematical operations like addition and multiplication, and functions like square roots or cosines. An equation gives information about the possible values of one or more unknown variables. Solving an equation is the process of finding all values of the variables that satisfy the equation. For the equation on the screen, you can check that x equals 2 and y equals 2 is a solution, but also x equals 4 and y equals minus 16. Then what makes an equation linear? Basically, linear equations are equations that can be constructed by using only two operations, addition and multiplication of a constant with a variable. For example, this is a linear equation. You see that it can be built from the variables x1, x2 and x3 and constants by using only addition and multiplication of a constant and a variable. However, this is not a linear equation. It involves a product of two variables and the function cosine. Both are not allowed in linear equations. More generally, we can define linear equations as follows. Suppose we have n unknown variables. Let's call them x1 to xn. An equation in those variables is called linear if it can be written in the standard form a1 times x1 plus a2 times x2, etc. equal to b, where a1 to an and b are numbers, also called scalars. These scalar factors in front of the variables are called the coefficients. The scalar on the right hand side is called, well, the right hand side. I'd like to go one step further. Often we are not trying to solve just one equation, but several equations simultaneously. Suppose you want to find the intersection point of two lines in the plane. Each line can be described by a linear equation. So to find the intersection point, we have to solve these two equations simultaneously. Such a set of linear equations is called a system of linear equations, or simply a linear system. A solution of a system is a choice of values for each variable such that all equations are satisfied. In the example, x1 equals 1 and x2 equals 2 is a solution, since with this choice of values both equations are satisfied. These are precisely the coordinates of the intersection point of the two lines. This is just one example of how a linear system may arise in applications. Even though they seem very simple, systems of linear equations occur in surprisingly many branches of science and engineering. That is one important reason to study them. Another reason is the following. There is one general method to find the solutions of any system of linear equations. And this is actually very special. For nonlinear equations, such as these, there is certainly no general solution method. In fact, for most nonlinear equations, there is no exact solution method at all. In this week of the course, you will study the properties of linear systems and learn how to solve them.